We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
There she is, NASA's Voyager 1, launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.
Greetings, planet Earth, and greetings to the universe, and welcome to our pilot episode of Space, the Final Frontier. I am Professor June Cahigal, and Space, the Final Frontier is a series of online lectures that would deal with science topics, especially in the fields of earth science, astronomy, meteorology, meteorology, cosmology, and other related fields. This is our way of reaching out to you, especially to the students out there, to share scientific information that would be useful in your schooling or online classes. So this pilot episode, we shall be focusing on the secrets of the moon. And if you have any comments or questions in mind, please feel free to comment or message below through the comment section or chat box. We would like to hear from you. So come join me as we explore our only natural satellite, the moon, through this pilot episode of Space, the Final Frontier. Hello and welcome to this virtual lecture entitled The Secrets of the Moon. I am Professor Jun Cahigal from the Bedan Society of Young Astronomers, and tonight is a special night for all of us. So tonight this virtual lecture is just fitting for the occasion. So we will now reveal the secrets of the moon. Now the moon is our only natural satellite. And in terms of its distance from the Earth, the moon is about 238,900 miles, or that's about 384,000 kilometers from the Earth. So that's the distance of the Earth from the moon. So that's about 384,400 kilometers. So that means that about 30 Earths can fit in that distance between the Earth and the moon. So 30 Earth diameters can fit between that orbit from the Earth and the moon. And about 101 moons can fit in that distance between the Earth and the moon. Okay, so isn't that really fascinating? Right? So 30 Earths can fit in that distance between the moon and the Earth, and 101 moons can fit between the Earth and the moon. So that's quite fascinating indeed. And you will be surprised that all the planets can fit between the Earth and the moon. So Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune can fit in that distance between the Earth and the moon. And about 8,030 kilometers, or about 4,990 miles of space to spare. So that's quite really fascinating indeed. Okay, so in terms now of its size, the moon's diameter is about 2,159 miles, or that's about 3,476 kilometers, about 27% of the diameter of the Earth. Or we can say that the moon is about a quarter of the Earth's diameter. So that's the size of the moon in comparison to the size of the Earth. Okay, so again, the moon is about 3,476 kilometers in diameter. The Earth is about 12,800 kilometers in diameter. So we can say that the moon is about a quarter of the Earth's diameter. Okay, so in the next slide, we have here our moon in comparison with the other moons in the solar system. So if you will just follow my cursor, so this is our moon. So the moon is slightly bigger than Europa. Europa is one of the moons of Jupiter. And Io, this is Io, which is also a moon of Jupiter, is larger than our own moon. Okay, Callisto is also larger than our own moon. The largest moon in the solar system is Ganymede. Okay, Ganymede is a moon, one of the 4 largest moons of Jupiter, as discovered by Galileo. Alright, so Ganymede is the largest moon in the solar system. Alright, but Mars is slightly bigger than Ganymede. Okay, so this is our own moon in comparison with the other moons of the solar system. Now, that's really interesting about the size of the moon in comparison to the other planets in our solar system. Now, the moon spins on its axis once every 27 days. So the moon's rotation means that its day is almost 2 weeks long, and then its dark also is for 2 weeks. And you will be surprised that the moon orbits the earth once every 27 days. So, as you could see, the moon spins on its axis every 27 days, and the moon orbits the earth, or the moon revolves around the earth every 27 days. So that means that the rotation of the moon on its axis is almost the same as its revolution around the earth. Now, this phenomena, wherein the rotational period of the moon is the same as its revolution around the earth, is known as synchronous rotation. So the moon orbits the earth once every 27 days, and also the moon takes about 27 days to revolve around the earth. So this is called synchronous rotation. And this is the reason why we only see one side of the moon. And that side of the moon that perpetually faces the earth is known as the near side of the moon. Okay? So this is the reason why we only see one side of the moon. It is because of its synchronous rotation. The moon is in synchronous rotation with the earth. Okay? And because of that, we only see one side of the moon. That side of the moon that perpetually faces the earth is known as the near side of the moon. And the opposite side is called the far side of the moon. No one has seen yet the far side of the moon until a Russian space probe visited the moon in 1959. The far side of the moon was first observed by humans in 1959 when the unmanned Soviet Luna 3 mission orbited the moon and photographed the far side of the moon. Now that really was an interesting aspect of the moon called synchronous rotation. And because of this synchronous rotation, we only see one side of the moon, and that's the near side. Okay, and we were able to see only the far side of the moon through the Soviet Luna 3 mission. Okay, let's talk about now the moon's albedo. Now, when you say albedo, this refers to the amount of light that a planet or a moon reflects back into space. And the moon's albedo is quite low. The moon's albedo is only 0.10 compared to Earth, which is 0.39. Now, in spite of the albedo of the moon appears bright in the night sky. Not because it is highly reflective, but it is close to us. Okay? So the moon looks bright in our sky not because it is highly reflective, but because the moon is so close to us. Okay? The albedo of the moon, like the Earth, varies depending on the terrain, varying from 5 to 10% for the Maria or seas to between 12 to 16% for the lunar highlands. Now, this is the reason why when we look through a telescope, the Marias or the seas appear darker. Okay, as compared to the lunar highlands and the impact craters, which are brighter as we look at it through a telescope. The dark areas or the dark patches of the moon, they are called seas by early sailors, but these are actually lunar plains. And the bright areas of the moon that's more reflective are the lunar highlands and impact craters. Okay, so everybody, I want you now to take a look at this photograph of the moon. Now, as you can see, those dark patches are called Marias or seas, as early sailors called them. Now, those dark patches are actually lunar plains. So they reflect less light as compared to the lunar highlands. So those bright areas that you see in the photograph are lunar highlands and impact craters. So they have higher albedo as compared to the Marias or seas or the lunar plains. Now the question is, why is it that the moon has a low albedo as compared to our planet? Now, it has something to do with the material on the lunar surface. Now, the bedrock of the moon's surface is covered by regolith. So take note, it's regolith. This is a layer of loose soil and rocks produced by meteorite impacts over the long history of the moon. Okay? And this regolith absorbs most of the light which falls on it. And that explains why the moon has a very low albedo of about only 0.10. Now that is really fascinating about the moon's albedo and the composition of the lunar soil. Alright, now let's talk about now the orbit of the moon around the earth. Now the orbit of the moon is not really a perfect circle, but the moon orbits around the earth in an elliptical path. So there are times wherein the moon is really close to the earth, and that's what we call the lunar perigee. And there are times wherein the moon is really far from the earth, and that's what we call the lunar apogee. Now, when the moon is at its perigee, or when the moon is really close to the earth, the moon looks slightly larger. Okay? And this phenomena that we see when the moon is at its perigee is what we call a supermoon event. Okay? So when the moon is at its perigee, the moon looks slightly larger. Okay? So we call this a supermoon event. Okay? Alright, so that's fascinating indeed. And in 2020, we have observed several supermoon events. Alright, and the moon's orbit is tilted of about 0.5 degrees. So that's the tilt of the moon's orbit around the earth, about 5 degrees. Okay, so that's the tilt of the moon's orbit. And the tilt of the moon's axis is only 1.54 degrees as compared to the Earth's axial tilt, which is 23.44 degrees. So the tilt of the moon's axis is very small. And what does that mean? So the moon does not experience significant seasons, unlike here on Earth, since the axial tilt of the Earth is about 23.4 or 23.5 degrees. The Earth experiences significant seasonal changes. So we don't see that on the moon because the axial tilt of the moon is only 1.54 degrees. Okay, so that's the tilt of the lunar axis. So let's talk about now lunar phases. Now when we say lunar phases, this refers to the shape of the directly sunlit part of the moon as viewed here on Earth. So as the moon revolves around the Earth, and from our perspective here on Earth, we see the moon changing shape from night to night. Okay? Alright, so let's talk about this in more detail about the phases of the moon. Okay, when the moon now is between the sun and the Earth, we don't see the moon in the night sky. Okay, so the sunlit part of the moon is opposite our perspective here on Earth, so we don't see the moon. So this phase of the moon is called new moon. Okay, and as we observe the moon from night to night, the moon gradually appears in the night sky as a waxing crescent. Now when you say waxing, it means that the moon is gradually increasing in size. In about a week, we would be able to observe a first quarter moon. And this is what we are waiting for, especially for amateur astronomers like us. We are waiting for that first quarter moon because the first quarter moon really is one of the best phases for viewing the moon using a telescope. Most of the craters are really visible during the first quarter phase of the moon. Then the moon, as the moon continues to revolve around the Earth, we would see a waxing gibbous moon. So when you say gibbous, this is the phase between first quarter and full moon. That's waxing gibbous. The moon is shaped like an egg or an oblong shaped moon. Alright, still the moon is fascinating to be observed during the waxing gibbous phase. In fact, tonight, September 26, the moon is in its waxing gibbous phase. Then after a week, we should be observing a full moon. A full moon occurs when the Earth is between the sun and the moon. And it's really fascinating to observe a full moon through a telescope, especially if the full moon is in its supermoon phase. Okay, then about a week after the full moon, you will notice that the shape of the moon is slowly decreasing. And this is what we call waning. So after full moon, you will now be observing the waning gibbous moon. So the shape of the moon is also like an egg. So when you say waning gibbous, that's between full moon and the last quarter. Alright, then after a week, we will be observing the last quarter. And after last quarter, a week later, we will be observing the waning crescent moon. Until after 27 days or about a month, then we go back to the new moon. Okay, so that's how we observe the moon as it revolves around the Earth. So the moon changes shape from night to night as we observe it here on Earth and as the moon revolves around our planet. Now here is an animated illustration to further demonstrate the different phases of the moon. So as you could see, as the moon revolves around the Earth, we see from our perspective that the moon changes shape from night to night because we only see that sunlit part of the moon as it revolves around the Earth. So we observe that as the different phases of the moon. So quite fascinating indeed. Okay, so those are the different phases of the moon. New moon, then you have waxing crescent, Then we have the first quarter, then waxing gibbous, then full moon, then waning gibbous, last quarter, waning crescent, and back to new moon. So that would take about 27 days or 1 month or isang buwan. And tonight, September 26, we will be observing the so-called waxing gibbous moon. And that's how we observe the moon as it revolves around the earth. Okay, so to continue, the moon has no atmosphere, so wala pong hangin sa buwan. And because of this, the sky appears dark even if you're on the bright side of the moon. So if you're on the lunar surface, like what the Apollo astronauts had experienced, the sky appears dark even if you're on the bright side of the moon. So everybody, take a look at this photo of an Apollo astronaut on the lunar surface. Look at the background sky. So the sky appears dark. Okay, look at this photo of an Apollo astronaut on board the lunar rover. And look at the background sky. The background sky is dark. Again, because the moon has no atmosphere. So wala pong hangin sa buwan. Okay? And because the moon has no atmosphere, there is no sound transmission on the moon. Okay, hindi po pwedeng mag-travel ang sound waves sa buwan kasi wala pong air molecules sa buwan. Kung meron, very feeble. So there's no sound transmission on the moon. So ibig sabihin nito, pag nanood kayo ng sci-fi movie na ang setting po ay nasa buwan at may pumutok. Kunyari, pumutok po yung spaceship nila, and pag narinig nyo yung putok na yon, imposible yon. There is no sound transmission on the moon. Okay? Now, through a telescope, the moon is scarred by millions of impact craters caused by comets, asteroids, and meteorites. Now, there is no atmosphere on the moon to help protect it from bombardment from these potential impactors. So that means that they don't burn up as they bombard the moon. Unlike here on Earth, we have an atmosphere, and as these meteorites enter the Earth's atmosphere, they burn up, but not on the moon. The moon has no atmosphere, so there is no way for these potential impactors to burn up. So they hit the moon's surface, creating those craters. Fascinating, isn't it? And many craters, including the Copernicus crater, exhibits patterns called rays. Okay, and these rays are caused by debris thrown out by the initial impact. This debris, called ejecta, can in turn create secondary craters when it falls back to the surface, as you could see in this picture of the Copernicus crater. Okay? Alright, so everybody, kindly take a look at this animated illustration of how an impact crater is created when an asteroid or a meteorite bombards the lunar surface. So you have that ejecta thrown out, and that would create those magnificent rays as seen here on Earth. Fascinating, isn't it? Okay. Okay. So these are photos of the Copernicus crater, and you could see here those rays radiating from the crater itself. Alright, so to continue, as seen through a telescope, there are dark patches and bright areas on the lunar surface. Those dark patches are actually lunar plains, and early sailors called them Maria or seas. And many astronomers believe that those dark areas or lunar plains are actually solidified pools of ancient basaltic lava. And the bright areas are lunar highlands and impact craters. Okay, so at this point, we will now proceed to our virtual moon gazing. So I'll be featuring some of my videos taken of the moon at the height of the community quarantine. So what I did is I have attached a webcam onto the eyepiece of the telescope. The webcam is hooked to my computer, so we can view the image of the moon virtually. Okay, so this is a virtual telescope viewing of the moon. So everybody just enjoy, sit back and enjoy the beauty of the moon virtually, since we cannot do yet any public telescope viewings. Okay, so everybody, let's watch this. Hi, and this is Professor Jun Cahigal. Welcome to this virtual online astronomy event. So we are here and we have this telescope already set up and we will be observing the moon. So come on, let's observe the moon. Hello, good evening. This is Astronomy at Home Quarantine Nights. This is Jun Cahigal, and tonight we are observing the waxing crescent moon. Okay, you could still see that curved terminal line. The terminal line is the boundary between the lighted area and the dark part of the moon. You can see it's still curved. So the moon is still shaped like a banana. So this is waxing crescent. Waxing meaning that the moon is gradually growing or increasing in size. Okay. So let us now increase the magnification and let's observe some details of the moon. Whoa. Wow. Fantastic. You could see now the details of the craters. Gosh. Wow. Ang ganda talaga ng buwan. Magnificent. Oh boy, sana makapunta ako dyan. Look at the detail of the moon. Okay. Fantastic. Wow. Look at all those craters. Yeah, we have seen these 3 craters at the center last night. Okay. And look at the Apennine Mountains at the center of the picture. Okay. Fantastic. Wow. The detail of the moon. Look at the detail. Fantastic. Oh boy. Alright, ladies and gentlemen, just check out those craters. Most of them are created from meteorite impacts. Okay. Fantastic. Okay. Alright, let's go back. Return to its normal size and magnification. Okay. There you have it, folks. That's our waxing crescent moon. Boy, clouds are building up. We're lucky tonight. Alright. So I hope the skies will be in our favor tomorrow, because tomorrow will be the first quarter moon. Hopefully we can observe that. Alright, so just check out our Facebook page, Vedan Society of Young Astronomers. Okay, so before we end, probably let's go into the details again of the lunar landscape. Whoa, wowee. Simply fantastic. Truly magnificent. Okay. All right. Okay. Hello, good evening. Welcome to Astronomy at Home Quarantine Nights. And for today, we are observing the waxing gibbous moon. Alright, yes, my dear netizens. So this is the waxing gibbous moon. Gibbous, so that means that our moon now is between first quarter and full moon. Okay, so that's our waxing gibbous moon. Alright, so for tonight, my observations will be composed of two parts. So this is now part 1. Okay, the usual observation of the moon, and later in part 2, I will be using a 2x Barlow lens to further increase the magnification of our image. Okay, so let us now magnify the image of the moon to examine more details. Whoa. Whoa. Alright, so you can see here the Copernicus crater. Okay. Alright, so that's the Copernicus crater right there. Wow, the detail. Okay, those dark areas are actually lunar plains. Okay, and this is the Tycho crater. So the bright areas are cratered and mountainous regions of the moon. Alright, at the center of the image is the Apennine Mountains. Alright, you can see now some details of our moon. Fantastic. Really fantastic moon. Ay, Diyos ko, hindi ako nagsasawa mag-observe ng moon. Okay. The moon's original name is Luna. Ayan. Okay, you can see now some details of our moon. Okay, so probably you know the legend, di ba? Pag full moon noon, maraming nababaliw. Kaya that's why we have the term lunatic. Lunatic. Okay. Wow, look at the detail of the moon. Fantastico. Wow. Wait. That's the Copernicus crater again. Wowie. Okay. Alright. Look at the detail of the moon. Okay, so let's return the moon to its normal size. Whoa. 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 Alright. That's our waxing gibbous moon, my dear netizens. Alright, so that basically ends our part 1 of our virtual telescope viewing for today. So later I will be attaching a 2x Barlow lens to this telescope, and we will see the moon in a higher magnification. Alright, so just appreciate the beauty of our waxing gibbous moon tonight. Let's increase the magnification again. Whoa. 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 Okay. The detail of our moon. So I'm doing this virtual telescope viewing for you. Again, because we are still in general community quarantine and we cannot do mass gatherings, public telescope viewings. So we are doing this virtual telescope viewing of our moon. Okay. Let's go back. Whoa. Okay. So just give me a few minutes and I will be attaching a 2x Barlow lens to this telescope. Okay, so see you in a couple of minutes for a higher magnification of our moon. Okay. Okay, so we are now observing the moon. If you will notice, the moon is larger than the previous image, right? Because I have attached a Barlow lens between the eyepiece and the telescope tube. A Barlow lens is like a telenegative amplifier. So what it does is it increases the focal length of the telescope and thereby increasing its magnification. But probably I will discuss further how a Barlow lens works in my future sessions. So right now we are viewing a magnified image of our moon. Alright, and I will magnify even further using the cell phone camera that is attached to this telescope. Okay, so let's zoom in now. Whoa, whoa. Alright, so at the center of the image is that's the Copernicus crater. Okay. And look at the detail. My gosh. Wow. That's the Copernicus crater. And over here is the Tycho crater. Alright, look at the detail of the lunar landscape. My gosh. Look at the detail of the lunar landscape. Wow, magnificent. Fantastic. Whoa, my gosh. Gusto kong pumunta sa buwan. Okay, the detail. Alright, so again, those dark areas are lunar plains, while the bright areas are cratered and mountainous areas of our moon. Alright, so that's again the Copernicus crater. Ganda. Magnificent. Fantastic. Grabe. Whoa. Look at the detail of that crater. Okay. Alright, so let's return the image to its normal size. Whoa. Alright, so this is our moon. This is the waxing gibbous moon. Okay, fantastic. Again, I am using a 2x Barlow lens for this image of our moon. Okay. Hello, good evening. This is Jun Kahigal from the Vedan Society of Young Astronomers, and welcome to Astronomy at Home Quarantine Nights. So we are still observing a full moon, but on its way to waning gibbous. Oh boy, the clouds. Okay, clouds are getting in the way of our observation of the moon. Okay, we have to wait it out for a while. Hintayin muna natin until the sky clears up. Okay, so in a few hours, the moon will be in its waning gibbous phase. So, pag sinabing waning, the moon will slowly decrease in size. It would appear smaller, gradually getting smaller. Okay, clouds are interfering with our observation. Okay, so I'll be back in a few minutes. Let's wait till the sky clears up. Okay, good morning, ladies and gentlemen. This is Astronomy at Home Quarantine Nights. And for tonight, we are observing the waning gibbous moon. So we are now halfway between full moon and last quarter. And if you will notice, the moon is not a perfect circle. Hindi siya bilog na bilog. Parang na siyang oblong. Okay? So that's the waning gibbous moon. Alright, so I just want you to look at this. This is our virtual telescope viewing of the waning gibbous moon. And just appreciate its beauty and splendor. Alright, ang ganda talaga ng buwan. Oh boy. I was walking in the moon one day. Gusto kong pumunta sa buwan. Yeah! Ay, Diyos ko. Gusto ko talagang pumunta sa buwan. Really fantastic. Amazing moon. Okay, so let us now zoom in and examine the moon in more detail. So let's magnify our image. Whoa. 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 All right. Look at the detail. Okay, so at the center of the image, again, we have the Tycho crater. Yan, ganda talaga. Grabe. Oh boy. Fantastic. Grabe talaga ang buwan. Super ganda talaga. Okay. Alright, so those dark patches again are lunar plains. Mga patag yan sa buwan. In fact, at the center of our image is the Sea of Tranquility. Diyan naglanding yung Apollo 11. Alright. Okay, so again, feel free. If you have any questions, feel free to ask them. Just message us. And we will try to answer your questions. So, tanong kayo about the moon or anything about astronomy. Just message us and we'll answer your questions about the moon or anything astronomy. Yan. Okay. O baka tanongin ninyo, may aliens ba sa buwan? Wala. The moon is a lifeless chunk of rock in space. So wala siyang atmosphere and there's no life. Okay. Pero hopefully we can colonize the moon. Sana we can construct lunar bases on the moon. And this is the stepping stone for a trip to Mars. Yan yung moon natin. Okay, so fantastic. Galing talaga ng buwan. Amazing detail. Okay guys, so if you have any questions, please message us. Kung meron kayong tanong about the moon or anything about astronomy. Yan. Okay. That's our moon. Bata pa ako talagang ino-observe ko na itong moon. Kahit wala akong telescope. Aakit lang ako ng bubong ng bahay namin and I'll just lie down and observe the moon, the stars. That's how I fell in love with astronomy. Tumanda lang ako, saka ako nakabili ng telescope. See, the passion is still there. Yeah, ganda talaga ng buwan. Amazing. Okay. Balik natin yung buwan to its normal size. Whoa. Whoa. Okay, there you have it. That's our waning gibbous moon. Okay, maswerte tayo. We have clear skies tonight, ladies and gentlemen. Sana ganito din yung bukas. Okay, let's magnify again. Whoa. Examine the moon. Alright, moony moons. Baka tanongin ninyo, ba't hindi natin makita yung bandera ng Amerika? Maliit yung mga yan. The flag is too small to be spotted by our telescope. Masyado yung maliit. Pero naglanding sila dyan. The Americans have landed on the moon. Okay, through Project Apollo. Okay. That's our waning gibbous moon. Okay guys, so kung meron kayong tanong, please feel free to ask them. Just message us. Kung di lang sa buwan, anything about astronomy. Or you can even share paano kayo nahilig sa astronomy. Okay, we would like to read or listen to your responses. Yan, mag-share lang po kayo. About the moon, kung bakit kayo mahilig sa buwan or anything. So just message us. Okay. Alright, so this is Jun Cahigal from the Belan Society of Young Astronomers. So just message us and we will try to answer your questions, or would you like to share? Magkwento lang kayo about your love for astronomy. We would love to hear it para ma-inspire naman po kaming lahat. Okay, so just appreciate the beauty of the moon. Well, I guess that's it for our pilot episode of Space, the Final Frontier, Episode 1, The Secrets of the Moon. I hope you have learned a lot about our moon, and I hope you were able to appreciate the images that I took of the moon using my telescope. This is our way of bringing the telescope to you, since we cannot do public telescope viewings yet due to the COVID-19 pandemic. So stay tuned next week to our exciting episode of Space, the Final Frontier. So always check our Facebook page, the Bedan Society of Young Astronomers, and always check our Twitter account. So this is Professor June Cahigal saying, live long and prosper, and I will see you next week for Space, the Final Frontier. Always stay safe, and goodbye everybody. Good night.
There she is, NASA's Voyager 1. Launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
To go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.